Assalamualaikum. Hi guys. So today we continue topic 3, hypothesis testing, focus on two population mean. Let's look at first case. So first case, both populations are normal. Variance from each population known. So known means that from the population, and last one for sure, independent samples. So there are 5 steps to conduct the hypothesis testing for two populations means. So first step here is, as usual, set up the H0 and H1. So look at here, when you compare the two population means, so H0 mu1 equal to mu2, or you can write like this, mu1 minus mu2 equal to 0. Meanwhile, the alternate hypothesis H1 based on the claim. So let's say claim stated less than, so mu1 minus mu2 less than 0. This one, mu1 minus mu2 greater than 0. And last one here is two-tailed test. Mu1 minus mu2 does not equal to 0. Next, second step here is calculate the test statistics value. So first case we will use Z calculation. Why? Variance for both populations are known, means from the population. That's why we will use sigma here. Sigma 1 square over n1 plus sigma 2 square over n2. Then look at here, x bar 1 minus x bar 2. And then this one, mu1 minus mu2 always or normally equal to 0. Then proceed to third step. So third step here is find the critical value. So this one, left tail test. That's why Z value left side. This one, right side. Why? Right tail test. But this one, either one, left or right side. Why? Two-tailed test. So where is the rejection region? First case, right here. Second case, here. And then third one is here for two-tailed test. And then step number 4, make a decision. And last one here is, as usual, after you make a decision, of course, you will conclude. So this one, step by step, how you want to perform the hypothesis testing for first case. As usual, don't forget this one. Reject H0 if P value less than alpha. So first example, past experience has shown that the time taken for high school juniors from school A and B to complete a particular task is a normal distribution with standard deviations of 2.8 and 3.5 minutes respectively. A random sample of 15 high school juniors from school A took a sample average of 26.2 minutes, and from school B it was 28.5 minutes to complete the test. At the 5% significance level, test the hypothesis that the average end time of school A is less than the end time of school B. So why this one categorized as case 1? So look at here. First sentence with standard deviations of 2.8 and 3.5 minutes. So this one, any word of sample? No. So 2.8 and 3.5 minutes is a population standard deviation for school A and school B. Okay, first, list all the information given. So look at here. Sigma, school A, 2.8. Sigma, school B, 3.5. Sigma represents population standard deviation. And then this one, X bar, sample average from school A, 26.2 here. And then school B, 28.5 here. And then the sample size, 15. 15 from school A, 15 from school B. Okay, next, set up the hypothesis first step. So this one, the symbol used is less than. Mu A minus mu B less than 0. Why? Look at here. Less than. School A is less than the end time of school B. So that's why here is less than. Or you can write as mu A less than mu B. Second step, calculate Z calculation value. So substitute all the values at the end. The final answer for Z calculation equal to negative 1.9874. Step number 3, find the critical value. So this one, we will use Z distribution. Consistent as here. Z calculation, of course, Z table. So from the table, when alpha equal to 0.05, left tail test, less than. That's why here is negative value, negative 1.6441. Step number 4, make a decision. So what is the decision? Reject H0. Why? Because Z calculation value less than critical value. You also can construct the rejection region. And last one, as a conclusion, at 5% level of significance, there is enough evidence to conclude that the average end time of school A is less than the end time of school B. Means that you will conclude the alternate hypothesis. Why? Because you reject H0. Now we focus on case number 2 and case number 3. So the difference between these two cases is right here. Equal variances, and then this one, the variance are unequal. So case number 2, equal variances, we will use this formula to calculate the test statistics. But for case number 3, also T calculation, but the difference is here, this one. And then the degree of freedom. For third case, you can use either one, using the formula or based on estimated degree of freedom. Third step, fourth step, and step number 5, same as usual. For hypothesis testing. The difference is for test statistic calculation and also the criteria of the cases. First, let's focus on second case. In a packing plant, a machine packs cartons with jars. The times it takes each machine to pack 10 cartons are recorded in the following table. So this one, new machine and old machine. Assume that the production time is normally distributed with equal variances. It is supposed that a new machine will pack faster on the average than the machine currently used. Do the data provide sufficient evidence to conclude that on the average the new machine packs faster? Perform the required hypothesis test at the 5% level of significance. First, why this study categorized as second case? So second case, recall back. Both populations are normal and then unknown variances and also independent sample. Is there any population variance or population standard deviation given in the statement? No. Just given the data. So, from the data, this data, you have to calculate the sample standard deviation or sample variance. So that's why this one categorized as second case, unknown variances and also equal variances. So first step, calculate. Let new machine denoted by number 1, old machine denoted by number 2. So this one, sample size, sample mean and also sample standard deviation for each population, for new machine and for old machine. Okay, next step. Second case using T. Two population. So, calculate unbiased pool estimate for standard deviation. So, calculate SP equal to 0.7175. Next step, proceed to 5 steps of hypothesis testing. Step number 1, set up the H0 and H1. So H0 as usual, mu1 equal to mu2 or mu1 minus mu2 equal to 0. H1, mu1 less than mu2. So here symbol is less than. So less than, why less than? The new machine packs faster. Means that the production time of the new machine will be less than the production time of old machine. So that's why the symbol used is less than. Next step, calculate T calculation. Substitute all the values using this formula at the end. T calculation value equal to negative 3.397. Next step, find the critical value. So this one, left tail test. So left tail test, the value should be negative value. What is the alpha value? 5%. So that's why here is 0.05. Next, degree of freedom. So degree of freedom, N1 plus N2 minus 2 here. That's why degree of freedom equal to 18. So the critical value equal to negative 1.734 from the T table. What is the decision? Reject H0 because T calculation less than negative 1.734. So what is the conclusion? At 5% level of significance, we can conclude that the data provides sufficient evidence to conclude on the average the new machine packs faster. So this one, the example to apply second case. So what happens if you are given a Minitab output? Same example, but Minitab output. So how you can conclude the claim? So same as previous lesson, reject H0 if the p-value less than alpha. So what is the p-value here? P-value equal to 0.002. What is the alpha value? 5%. Is it p-value less or more than alpha value? Less than alpha value. So, first step, set up the hypothesis. Second step, p-value equal to 0.002. Alpha equal to 0.05. So decision reject H0 because p-value less than alpha. So what is the conclusion? At 5% level of significance, we can conclude that the data provides sufficient evidence that on the average the new machine packs faster. So this one, how you want to conclude based on Minitab output. Always remember that reject H0 if p-value less than alpha. Okay, so now this one is case number 3. So recall back. Case number 3, both populations are normal, unknown variances, and also unequal variances. And also the sample should be independent. So let's focus on third example. ABC Furniture Factory produced large cupboard using two different production methods. Sample data on the production time for the two methods are given below. Assume that the production time is normally distributed with unequal variances. So this one, direct statement. That's why this example categorized as case number 3. So the question asks you to test the hypothesis that the traditional method produces higher mean production time than the experimental method. Use the 0.05 level of significance. So first step, let's traditional method denoted by number 1. Meanwhile, experimental method number 2. So first step, set up the H0 and H1. So H0 mu1 equal to mu2. H1 mu1 more than mu2. So more than mu2 based on this one. Traditional methods produce higher mean production time than experimental method. That's why mu1 more than or higher than mu2. So second step, calculate T calculation value. So this one, we will use this formula. Third case, substitute all the values. So T calculation equal to 2.3243. Next, find the critical value. So critical value, T calculation. So here, T value for critical value. So from the T table, when alpha equal to 0.05 and then degree of freedom equal to 24, why 24? Here, use estimated degree of freedom means that which one is larger, 25 or 21? 25. That's why 25 minus 1 equal to 24. So degree of freedom 24. So the critical value equal to 1.711. Positive value. Write tail test here. This symbol. Step number 4, decision. So reject H0. Why? Because T calculation more than or greater than the critical value. As a conclusion, at 5% level of significance, the data provide sufficient evidence to conclude that the traditional method produce higher mean production time than the experimental method. So this one, the example to apply case number 3. Both population are normal, unknown variances, and also unequal variances. Case number 4, populations are normal. So this one based on dependent sample. So dependent sample, how to set up the H0 and H1? Right here. Mu D, we will use D. So D stands for difference. So H0 mu D equal to 1. And then H1, 3 types of H1, either 1, mu D less than 0, mu D greater or more than 0, mu D does not equal to 0. And then for task statistics, we will use this formula, whereby degree of freedom equal to n minus 1. N is number of pairs. So step number 3, calculate T calculation. So we will use T table to find the critical values and also to draw the rejection region. So first one, left side, left tail test. Second one is right tail test. And then last one, two tail test. So the one is rejection region. Step number 4, make a decision. So decision based on T calculation compared to the critical values. And last one, as usual, of course, we will conclude the statement. So if given from the Minitab, always remember that reject H0 if p-value less than alpha. Let's try this example. So this example is based on dependent sample before and after. So using the Minitab value, test the effectiveness of the vitamin regimen at 1% level of significance. So look at the Minitab output. So t-test of mean differences here equal to 0 versus does not equal to 0. So H0 mu D equal to 0, H1 mu D does not equal to 0. Second step, from the Minitab output, identify the p-value. So p-value 0.2 0.208. What is the level of significance? Here, 1%. So 0.01 when you convert to decimal form. So what is the decision? Fail to reject H0. Why? Because the p-value 0.208 less than 0.01. Therefore, at 1% level of significance, there is enough evidence to conclude that on average, the vitamin does not increase the strength. Here is the confidence interval approach. So let's say a medical researcher is interested in studying the effectiveness of two types of vaccines to treat diseases caused by the new coronavirus. 25 samples were taken to measure the cure of the disease after the vaccine injections were administered. The statistics are given in the following table. So this one, the sample size, the sample mean, and also the sample standard deviation of each vaccine. Assume the two populations are normally distributed with equal variances. First question, construct a 95% confidence interval for the difference in the mean hours between vaccine A and vaccine B. So first question, calculate the unbiased pool estimate. Why? Two population, and then this one, the sample size less than 30. Therefore, we will use T. So, T for confidence interval, case number 3. And then calculate unbiased pool estimate as P equal to 111.6602. So we will use this formula to calculate 95% confidence interval, substitute all the values, and then from the T table find 0.025, degree of freedom equal to 48. So at the end, 95% confidence interval in between negative 23.5752 and 103.5752. So this one, the confidence interval to answer first question. Second question, question B. Based on the interval obtained in A, what conclusion can you make on the effectiveness of the two vaccines? Justify your answer. Means you want to use the confidence interval values here to support your answer for question B. So is it the effectiveness of the two vaccines equal effective or not? So look at the interval value. Is it any zero value within the interval? Yes. Therefore, based on the interval, both the vaccine A and vaccine B are equally effective because the value of 0 is in the interval here. Lower limit or lower bound, negative value. Upper limit or upper bound, positive value. So for sure, 0 is in the interval. That's why both vaccines are equally effective. But let's say the interval value obtained like this, negative 23.5752, and then here is negative 1.3456. So what is the conclusion? Is there any zero between the interval? No zero, right? Because both are negative values. So the conclusion is not equally effective. Why? Because the value of 0 is not in the interval. So that's why when you want to conclude the claim or the test based on confidence interval approach, you can use the zero value concept. Equal or does not equal based on the zero value. Okay guys, that's all about the hypothesis testing of two population means. Assalamualaikum.